Good day, grade 8 learners. Now we're going to discuss about simplifying rational algebraic expressions. What I need to know. At the end of the lesson, you are expected to first, recall factoring polynomials and demonstrate understanding through organized solution and correct answer in simplifying algebraic expression. What's in? Activity 1, Factor Me. Instructions. Choose from the banner the correct factors of each polynomials. Number 1, 26 plus 39x. Number 2, AB plus AD minus BC minus DC. Number 3, 3x squared minus 27. Number 4, v squared minus 6v plus 9. And number 5, we have v squared minus 3v plus 2. So this time, you're gonna choose the correct factors from the banner. So we have here the choices. The quantity of b plus d times the quantity of a minus c. We also have the quantity of v minus 3 squared. We also have here the quantity of v minus 2 times the quantity of v minus 1. Here also is 13 times the quantity of 1 plus 2x. Another choices is 3 times the quantity of x minus 3 times the quantity of x plus 3. And the last choice is 4x minus 3. Now let's proceed to number 1, 26 plus 39x. As you can see, number 1 is a binomial. So, to get the factor of number 1, all we have to do is to get the greatest common monomial factor first and the remaining factor. So in this case, our greatest common factor for 26 plus 39x is 13, and our remaining factor is 2 plus 3x. So as you can see, you cannot see the answer in the banner. So all you have to do is just to write your answer on the blank. And the answer for number 1, 26 plus 39x is equal to 13 times the quantity of 2 plus 3x. Now let's proceed to number 2. AB plus AD minus BC minus DC. So this time, our goal is to get the factor with A, B, C, and D. So in our banner, the only choice that we have with A, B, C, and D as factors is this one. The quantity of B plus D times the quantity of A minus C. Therefore, it is the answer for number 2. Now let's proceed to number 3. 3x squared minus 27. So in the banner, so there are two choices with x. So therefore, we have to solve this number 3. So here, since number 3 is a binomial, all we have to do is to get the greatest common monomial factor and the remaining factor. The greatest common monomial factor for 3x squared minus 27 is 3, and the remaining factor is x squared minus 9. And as we all know, x squared minus 9 is a perfect square. So therefore, all we have to do is just to extract the x squared, and the 9. And we got x minus 3 times the quantity of x plus 3. So, our factor for 3x squared minus 27 is equal to 3 times the quantity of x minus 3 times the quantity of x plus 3. And that is the answer. Now let's have number 4, v squared minus 6v plus 9. So, as you can see with the pattern, number 4 is a perfect square trinomial. And following the pattern a squared minus 2ab plus b squared, we are expecting to have a factor a of the quantity of a minus b squared. So, from the banner, the only factor with that pattern is this one, the quantity of v minus 3 squared. And using the FOIL method, we can check that v minus 3 times the quantity of v minus 3 is equal to v squared minus 6v plus 9. Therefore, v squared minus 6v plus 9 is equal to the quantity of v minus 3 squared. Now let's have the last number, v squared minus 3v plus 2. So from the banner, it is obvious that the answer is the quantity of v minus 2 times the quantity of v minus 1, because it is the only choice with v as one of the factors. But just take note that in getting the factor of number 5, you have to think of numbers in which when you evaluate, you can get the negative 3v as the middle term and the last term as 2. So using the FOIL method, we can evaluate the factors, the quantity of v minus 2 times the quantity of v minus 1. Therefore, v squared minus 3v plus 2 is equal to the quantity of v minus 2 times the quantity of v minus 1. Great job, as you were able to recall your knowledge in factoring when you answered Activity 1, Factor Me. Take note that as we go through this lesson, you will not only remember factoring, but you will also be able to link your previous knowledge on the law of exponent and finding the greatest common factor, as this knowledge will play a vital role in this lesson. Would you like to know how? Now let's proceed. What's new? Write the following in the lowest form. So let's have this number 1, 13 over 26. To reduce a fraction to lowest terms, all we have to do is to divide the numerator, the numerator, to its denominator by getting their greatest common factor. This is also called simplifying fraction. The greatest common factor of 13 over 26 is 13. Therefore, we divide both the numerator and the denominator by 13. So therefore, its lowest term is equal to 1/2. Now let's proceed to number 2. We have 13x squared over 26x. So, to reduce 13x squared over 26x to lowest terms, all we have to do is just to factor both the numerator and the denominator. So we will be able to get 13 times x for the numerator and 2 times 13 times x for the denominator. And this time we're gonna get the greatest common factor for numerator and denominator. And we will have 13 and x. And to simplify, we just have to divide both numerator and the denominator by its common factor, so we will be able to get x over 2. Yes, you have learned in the previous years of studying that in reducing a fraction in lowest term, you have to divide the numerator and denominator by its greatest common factor. And that's how you answered number 1. But how about number 2, in which it already involved a variable? How did you come up with the answer? That is what we are going to find out in this lesson. What is it? Just like rational numbers, rational algebraic expressions can be reduced to lowest terms, and that process is known as simplifying rational expressions. To reduce or simplify to lowest terms, the rational expression, factor the polynomials in the numerator and denominator first, then cancel all common factors, or divide the numerator and denominator by their common factors. Let's take these illustrative examples. Let's have simplify each of the following rational expression. And let's have number 1, x squared y over 4x y squared. The first thing that we're going to do is to factor the numerator and the denominator. So we have here the factor of x squared y is x times y over the factor of the denominator 4xy squared is 4 times x times y times y. The next step that we're going to do is to group the common factors in the numerator and denominator and cancel the common factor both in the numerator and denominator. So we have here we have x as one of the common factor for numerator and denominator, and another common factor is also y, so we will cancel that one. So the remaining factor is x over 4 and y. Just take note that in this example, we can also have the power of quotient, in which a to the power of m over a to the power of n is equal to a to the power of m minus n. So therefore, we can just subtract the common exponent. We can just subtract the exponent as long as we have the common base. So, the simplified form of x squared y over 4xy squared is equal to x over 4y. Now, let's have number 2. Our rational expression is x squared minus 6y squared over 3xy minus 6y squared. Once again, you have to remember your knowledge in factoring. So factor first the numerator x squared minus 6y squared, and we all know that this is the difference of two squares. We have the quantity of x plus 3y times the quantity of x minus 3y over the denominator. The factor of 3xy minus 6y squared is 3y times the quantity of x minus 3y. Next is to group the common factors in the numerator and denominator and cancel the common factor. So we have here the common factor for both numerator and denominator is x minus 3y. So cancel this out. So the simplified factor for x squared minus 6y squared over 3xy minus 6y squared is equal to x plus 3y over 3y. And take note, you cannot cancel out the numerator and the denominator 3y because the numerator is a binomial and the denominator is a monomial. Now let's proceed to our third example. 7x squared plus 28x over x squared plus 8x plus 16. So let's simplify this rational expression. So the first thing that you're going to do is to factor first the numerator by getting the greatest common monomial factor and the remaining factor of 7x squared plus 28x. So we got here the greatest common monomial factor, which is 7x, and the remaining factor, which is x plus 4. Yes, so after factoring the numerator, this time let's proceed factoring the denominator. So we have here x squared plus 8x plus 16, and as we all know, it is a perfect square trinomial, so we got the quantity of x plus 4 times the quantity of x plus 4. And again, using the FOIL method, we will be able to check that this is just the factor of x squared plus 8x plus 16. And after factoring both the numerator and the denominator, we have to cancel out the common factor, which is x plus 4. So as you can see, there is a common factor. So cancel this out, and the remaining factor would be 7x over x plus 4. Therefore, the simplified rational expression of 7x squared plus 28x over x squared plus 8x plus 16 is 7x over x plus 4. Now let's proceed to our next example. Our rational expression is 4x squared plus 4x plus 1 over 2x cubed plus 11x squared plus 5x. So let's factor first our numerator. So take note that 4x squared plus 4x plus 1 is a perfect square trinomial. And following the pattern, the quantity of a plus b squared is equal to a squared plus 2ab plus b. So in this case, we have to extract first the first term and the last term. So our first term is 4x squared and the last term, which is 1 as our constant. Again, take note that our pattern is a squared plus 2ab plus b. So we need to get the simplified form, which is a plus b, the quantity of a plus b squared. Right? So therefore, when we extract the first term 4x squared, it is now equal to 2x. And the last term, when we extract the square root of 1, the answer is still 1. So with that, we already have 2x and 1. So all we have to do is just to copy 2x, then 1, and just copy our operation, which is positive or addition. So therefore, and we will make it square following the pattern. So we have here 2x plus 1 times the quantity of 2x plus 1 as the factor of our numerator. Now let's factor our denominator, 2x cubed plus 11x squared plus 5x. So as you can see in our expression, 2x cubed plus 11x squared plus 5x, there is a common factor which is x. So therefore, it will become x times the quantity of 2x squared plus 11x plus 5. Yes, and so this is now our new expression. And in order to get the factor of this, so we need to factor this by grouping. So we have to factor out the middle term. Yes, so in order to factor this, so it will now become x times the quantity of 2x squared plus 11 times x plus 5. Yes. And this time, our goal is to factor this out, to have a new factor of this by grouping. So we need to split the middle term. Yeah, so that we will be able to factor by grouping. So in this case, our goal is to have a result in which when we multiply our first term to the last term, so it will become the result will become 10, and when we add the result 10 to the other factor in the middle, it will still result to 11. So therefore, that number or that factors are 1 and 10. So in this case, we will be able to have this new expression, x times the quantity of 2x squared plus 1 plus 10 times x plus 5. So applying the distributive property of multiplication, so 1 times x, then 1 times 10. So 1 times x is equal to x, then 10 times x is equal to 10x. So adding them both, it will still result to 11x. So in this case, we can already factor this out by grouping. So how are we going to do that? All we have to do is just to factor out the first term and the second term, and then factor out the third term and then the fourth term. So it will now become like this. So we will have the new factors, x times the quantity of 2x squared plus 1x. Yes, so we have here 1x plus 10x plus 5. So the third term and the fourth term. So this is now our grouping. Now, this time, we can still factor this out by getting the greatest common factor of this expression. So we will be able to get, yes, we will be able to have the new expression. So we will have x times the quantity of x times the quantity of 2x plus 1 plus 5 times the quantity of 2x plus 1. And as you can see, our common factor is 2x plus 1. So that is our greatest common factor. So therefore, all we have to do is just to copy that one. So copy this also, this x, the factored out x. So copy the 2x plus 1. And the remaining factor, which is x plus 5. So when I rewrite that one, it will become, we have now x times the quantity of 2x plus 1 times the quantity of x plus 5. And now we can already proceed to canceling out the common factor in the numerator and then the denominator. So we have here 2x plus 1 as our common factor between the denominator and the numerator. So we will cancel that out. So our remaining factors are this. Okay? Therefore, the simplified rational expression of 4x squared plus 4x plus 1 over 2x cubed plus 11x squared plus 5x is 2x plus 1 over x times the quantity of x plus 5. You have to take note that in simplifying rational algebraic expression, your knowledge in factoring, law of exponents, greatest common factor is really vital in this lesson. So remember the following ways of factoring polynomials: the difference of two squares, the sum and difference of two cubes, the perfect square trinomial, the trinomials in general, or we also have factoring by grouping. Now, let's check your understanding. What's more? Activity 2. You have to reduce. Instructions: write each expression in lowest terms on a separate sheet of paper and show your solution. For number 1, we have 12c cubed d to the power of 7 over negative 48c to the power of 5 times d cubed. Number 2, we have 12 times z cubed over 6z. We have number 3, 12 times the quantity of y plus 2 over 18 times the quantity of y plus 2. And we also have number 4, y squared minus c squared over y plus z. And number 5, y squared minus 3y over y squared plus 4y minus 21. Again, show your solution. What you need to remember in this lesson is, in simplifying rational algebraic expression, factor the numerator and denominator using your knowledge in factoring, then cancel all common factors and apply the law of exponent when necessary. Second, if a, b, and c are polynomials, then ca over cb is equal to a over b, where b and c are not equal to 0. The value in the denominator must not be equal to 0. Alright, and that's the end of our simplifying rational algebraic expression lesson. So I would like to end you with this quote: don't give up. The beginning is just always the hardest, but do not give up. So I hope you learned something from this lesson.